Hello friends, we're going to talk about forces in motion today. Hopefully you read the book pages about forces in motion, and we're going to talk about the notes. I am going to put copies of the notes in a folder as well, so that way you can write them at your own pace, or you can write them as we do the video and just pause it as necessary. First thing is we're going to title it Forces in Motion. Then I'm going to have you go ahead and glue down or tape down your vocabulary list. There are 5 words this time. Your quiz will be shortly after you get back, and they are on Quizlet. It's called Unit 8, Forces in Motion. The first word is balance forces. Those are forces on an object that are equal in size and opposite in direction. So if 2 people were tug-of-warring and they were exactly equal in strength and nobody was moving in either direction, that's balance forces. When I lean against a wall, that's balance forces. I'm pushing into the wall's pushing into me, neither is moving. A force is a push or a pull. Friction is a force that opposes motion. So on the bottom of your sneakers, it's kind of rigid and stuff, and that's so that there's friction, so that you don't fall and slip on, say, tile floor. It opposes that motion. Gravity is a force of attraction between 2 objects, and unbalanced forces are forces that cause a change in motion. So back to the tug-of-war example. If the people are tug-of-warring and then one team is stronger than the other, it's going to cause the other team to change motion and be pulled the other direction. Okay. The next page of notes says, what are forces? And you're going to just go ahead and cut out and glue down this portion. So it's not the whole page. It was in your take-home folder that looks like this. It says, all changes in motion have one thing in common. They require a force. That's a push or a pull. Forces can make an object start to move, speed up, slow down, change direction, or stop. They can also change an object's shape. Forces are measured in newtons. We do a capital N as the abbreviation with a spring scale usually. And greater force requires greater change. Smaller creates small change. So if I apply a great force, like a great push, it's going to be a greater change where the item's going to go far. If I do a small force, it's going to be a small change where the item doesn't go that far. Then there are 3 pictures. Picture A. You're going to go ahead and label it A, and you're going to write, when the ball hits the floor, the force stops it and changes direction. Same when the ball hits your hand. So it can change direction. Then we're going to label the middle one B, and we're going to go ahead and write, when the rower pulls back on the oar pushes against the water. And finally, we're going to write C, and it says, the horse and the road exert a force on the cart. And we can see from C that the horse is pulling, remember pulling is a force, the cart in that direction. On the next page of notes, I labeled it gravity and friction. And then it says, gravity is a force of attraction between 2 objects. The size of the force increases as the mass of the object increases. Earth pulls or attracts us to the ground. And this is from another page in your folder that you took home. You're going to cut this portion out to get that. And then it says friction. Friction is a force that opposes motion, acts between 2 objects that are touching, like bike tires in the road or sliding on a smooth surface. So you can see I have arrows pointing at each of these 2 pictures, and I kind of wrote some stuff there. So in this first picture, I have an arrow, and it says, the floor is touching your feet, which you are pushing or sliding across. And there's not that much friction here, because when you have a tile floor and you have socks, there's really not much friction, and that's why you're able to slip and slide. If I had sneakers on the carpet and I try to slide, it's not going to really happen because there's too much friction, so it opposes or stops that motion. For this picture, you can see it says, the road is touching your tires, which are pushing against it when moving. Now, and it's kind of pointing there for that. All right, now you're gonna cut this other section off, and it says air resistance, and that's the friction that exists between air and a moving object, like a hockey table. When it's on, there's a little bit of air there, and it makes it more slippery, and actually that way there's less friction in that case, and the puck goes pretty smoothly across the air hockey table. When it runs out and the air is not there, it's a little bit harder to play because there's more friction. With a parachuter, you can see that it says gravity is pulling the parachuter down, and then air resistance is kind of pushing him up. So basically this whole surface of his body, because his hands are out and his legs like that, it's creating more air resistance or friction. And also, I did want to point out something that I kind of mentioned earlier at the top of this set of notes. The more mass something has, the more force is required to move it. So if you picture a little kid and then a sumo wrestler, it's going to take a whole lot more force to move that sumo wrestler than the little kid if you go to push them, which hopefully you wouldn't be pushing people anyway, but just saying. And if I did the same force on both of them, the sumo wrestler and the little kid would obviously have a much larger distance and velocity speed that it moved than the sumo wrestler, which might just move a little bit. The last page of notes say force and mass, and you're gonna cut and glue down this page again from the folder you took home. It says forces. Balance forces are forces on an object that are equal in size and opposite in direction. They cancel each other out like sitting in a chair. Gravity pulls you down, the chair pushes you up. Tug of war game, well, until one side exerts more force. So tug of war when it's equal. So I drew an arrow. This is balance. You can see they're pulling with the same amount of force. All right, then we have unbalanced forces. Those are forces that cause a change in motion. For example, when the side gives more force at tug of war game and one team falls down. So they're exerting 400 newtons of force and they are doing 300. So what's going to happen is they're going to try and pull this way and boom, they're going to actually go flying that way because they're exerting more force. That's unbalanced forces. It also says dominoes falling after you've set them up. So when the dominoes are all standing on the table, that's balanced. But once they start falling down and changing that direction, it's unbalanced forces. All right, and then down at the bottom, it says a large force will cause greater change in the motion of an object. A smaller force will cause little change. Kind of going back to the example of the sumo wrestler and the little kid. So I kind of drew an arrow and I labeled it, the harder you hit the cue ball is the white ball in billiards or pool, the greater the force will be on the other balls. So if I do a little hit on the cue ball, it'll be a little force on the other balls. A big force on the cue ball makes a big force on the other balls. And then I drew an arrow pointing to here, the test your strength thing, the carnival game. And it says the harder you hit the button, the higher the piece will go towards the bell. So in your book pages that you read, I know it talked about an adult and a child hitting it. And it said the adult hit it and it hit the bell. When the child did it, it didn't hit the bell. Well, that's because the child wasn't using as much force. So it didn't make its way all the way to the bell. And at the very end, it says mass. The less an object's mass is, the less force needed to change its motion. So, for example, pushing an empty shopping cart versus a full one. So if I go to Costco or Sam's or BJ's or somewhere like that, when I first get my empty shopping cart, I don't need much force to push that around. But as I'm loading it with heavy waters and groceries and stuff, it's going to take a whole lot more force to move it because its mass is heavier. All right, guys. So I hope that you are able to complete your notes and cut and paste and add in the writing, all that you need to. And I hope this makes sense. And when you get back, I will continue on with forces to make sure it's nice and clear. All right. Miss you guys. Bye.